The purpose of this demo is really just to illustrate anonymous inner classes. So to that end, we're not going to spend a lot of time looking at the details of the code. It would be useful for you to type this program in yourself and play around with it and see how it works. I'll point out a few details about how it works, but I really do want to focus on the aspect of it containing anonymous inner classes. So if we go ahead and run it, we get this. And that little piece of text that you see up there, programming is fun, we can move it around by clicking the up button, the down button, the left button, and the right button accordingly. So obviously we're going to have 4 listeners listening to these 4 buttons and responding to them appropriately. And we're going to look how that's implemented using anonymous classes. As I said, I'll point out a few things about some of the details of the demo that are outside the context of anonymous classes, but really I want to focus most of our time on discussing how the anonymous class aspect of it is implemented. So first of all, if you click up as many times as you can and left as many times as you can, you find that the furthest up and left you can locate the text is where you see it now. I won't go through the details with you, but I'll let you look at the code yourself to see where the author has written code that protects us against getting outside of this window. In fact, you remember we talked about the fact that the anchor point for the XY references to the text is actually sort of the bottom tail of the P here. And in fact, if you put that at 0, 0, it would appear right here in the corner of the window, which means all but the descenders, the tail on the G and the tail on the G. And in this case, it doesn't look like the F has a descender as we saw last time. The italics F does have a descender, interestingly, but the non-italicized F does not. But the descenders are still present here on the G's. So if we put this text at 0, 0 in the window, just the tails of the G's would be showing, and in fact, it would be way up here. So that's been taken into account when the author wrote the code to protect how far left and how far up it can go. And if you check out the code for going to the right and down, he's put some similar checks and balances in there to prevent the code from, or to prevent the programming is fun from going down all the way outside the window. And when we go right, again, it can't go further than that. So I'll let you have a look at the code and determine for yourself how exactly that got implemented, but we won't spend time worrying about it right now. Rather, let's focus on the idea that we do have anonymous inner classes in this code that we want to look at. These occur in the listeners for all 4 buttons, and I'll just highlight the code associated with that for you. So it's this section right here. You can see there's clearly 4 individual sections, 1 for each of the buttons. Each of these has implemented an anonymous inner class. So we won't talk about them all. We'll just pick apart one all by itself and just focus on just a single one of these. So we're now zoomed into just this one particular event handler or listener that we have. It's for the down button, as you can see, button down dot set on action, and inside of here we have an anonymous inner class. Let's see how that works. Well, first of all, notice that this opening brace goes with this closing brace way down here, and then of course everything's followed by a semicolon. What would normally go there would be the name of the listener, but because this is anonymous, it doesn't have a name. So in that pair of parentheses, and again, this is the entire group of all the 4 or 5 lines that you see here, enclosed in that round parentheses, is the anonymous inner class. So recall how we said we were going to do that. We don't give it a name, we simply say new, and we give it the class name that it's extending. It's actually implementing the event handler. So we have new event handler, and we give action event as the particular type that we're interested in using here as the generic type. And then immediately we have the code. So there's a curly brace to say, okay, here's the code that represents our override or our reimplementation of, or implementation actually, of event handler. So the curly brace that goes with that curly brace, once again, is way down here. So we now have an entire implementation for this listener inside of those round parentheses. It hasn't been given a name, therefore it's anonymous, and is defined right inside of here, therefore it's an inner class. So it's an anonymous inner class. The actual code is then here and starts by saying, okay, we're overriding something. That is, we have an existing handle method in the event handler interface, and we're going to override that right here and now. We declare public void handle action event consistent with the abstract method that corresponds to this in the event handler interface that we're overriding. Then this next pair of curly braces that starts right here and ends right here is the actual overriding of that particular method. And what we do here is we say text.setX text.getY is less than pane.getHeight. So this is a conditional. You see the question mark right here. So this is a Boolean value that's going to be checked for true or false. If it's true, then the argument to text set y is going to be what you see before the colon. If, on the other hand, this condition right here is false, then the argument that sits in here in text.setY will instead be the value of whatever this is. So we're either going to add 5 to the current y value and set the new y value to that, or if it's gotten too big and we're hitting against the edge of the pane, then we're just going to set it equal to pane height and not allow it to go any further than that. In any case, that's the response now to the click of the button, and you can see how we've defined it now as an inner class that has no name, therefore it's an anonymous inner class.